Hi, it's Mrs. Lemoyne again, and today we're going to be doing Illustrative Math Grade 5, Unit 2, Lesson 13, Area and Properties of Operations. We're going to start today by writing expressions to represent the area of rectangles. So let's jump up into our warm-up, which is a number talk today. Find the value of each expression mentally. All right. When I first look at this problem, I notice that there are some parentheses, and there's some multiplication and some addition. And I remember from fourth grade that there's an order of operations, right? I have to do things in a certain order. So remember PEMDAS, parentheses, exponents, multiplication and division in order from left to right, addition and subtraction in order from left to right. So I have to do parentheses first, then exponents, then I can do multiplication and division, then I can do addition and subtraction. But in this case, I have addition inside my parentheses, so I have to do that first. So I know that 5 times 7 plus 4 is 11, so that's going to be 5 times 11. So the answer is going to be 55. 55. You could have thought of it in a different way. That's the way I thought of it. Now I notice I can do the parentheses first, so 5 times 7 is 35, and 5 times 4 is 20. And when I add 5 and 0 is 5, not 0, 5. And 2 and 3 is 5. So I got the same answer. So that tells me there's some commonality between these two problems. But I know there's something called the distributive property. And what that means is anytime there is a number outside of the parentheses and multiplication, right, I can distribute that 5 to everything inside the parentheses. So the 5 goes to the 7, and the 5 goes to the 4. That's called the distributive property. I took the 5 and I distributed it to everything inside the parentheses. And then I get the 35 plus 20, and I get the same answer. So it's another way of doing this problem, is this one. All right, moving on ahead. Now I have a fraction in my parentheses there. Let's worry about this one first. I know 5 times 7 is 35. And I'm going to multiply 5 times 1/4. That's 1/4 5 times. So that would be 5/4. Well, that's an improper fraction. And I know that there is a 4/4 inside of that 5/4. So that means there is a 1 inside of there, right? And then what's left over? Well, there's going to be one more fourth. So I'm going to add that to 35, and I'm going to get 36 and 1/4. All right, and then the last equation, or expression I should say, let me get rid of this so we can see it. 35 minus 5/4. Or we could say 35 minus 1 and 1/4, because that's what we decided that this is, right? So I know that I'm going to take 1 away from the 35 and get 34. But then I still have to subtract 1/4, right? 1/4 from that. And there's nothing to subtract from. But I know that I'm going to have to take apart 1 from here, and I'm going to make that a 33. And the 1 that I took away, right, I'm going to have to subtract, and that would be 3/4. 3/4. All right. A little warm up for today. Let's move on to the first activity. So we're going to get some cards, and we're going to have to do a card sort. So let's go ahead and get that set up. I have some cards here. First, let's read the directions. Your teacher will give you a set of cards. Sort the cards in a way that makes sense to you. Match each expression, these are the expressions, to a diagram. And of course, there are more expressions than there are diagrams, so that some diagrams are going to have more than one expression. So let's take a look at that, and then you can share with your partners. Okay, let's get to my overhead. Here are my cards. So I have card A. Card A looks like it is 1, 2, 3, and 2/5. 1, 2, 3, 4, 5 at the top. So 5 and 3 and 2/5. Well, there's a card that matches with that already, isn't it? Right? 5, 1, 2, 3, 4, 5, and then 3 and 2/5. So I'm going to match that one. Oh, I'm looking at F. F looks like the same thing, right? Because remember that this can be the same as this. So these two match with A. This is a 2 and 2/5, so I know that that's not going to work. Put that over here. Another 2 and 2/5. So this says 3 times 5 plus 3 times 2 and 2/5. Well, I'm not sure that this one works because I see the 5 and I see the 3 and 2/5. I don't think I need to multiply 3 times 5. I don't need to multiply 3 times 2/5. So I'm going to put that one over here. That one looks a lot like the same, except this time they're doing 5 times 3 and 5 times 2/5. I don't think that one applies. Let me make sure. 5 times 3 would be this one. Oh, this one does apply. So then 5 times 2/5. Yeah, I think this one works. 1 second. All right. Then I have 5 times 17/5. Well, let me think about that. 17/5. So if this was 2/5, 1, 2, 3, that would be 3 times 5/5. Yeah, I think that one fits as well, right? So that is just the improper fraction for 3 and 2/5, right? Because if I broke all of these up into fives, from here to here, that would be 1, 2, 3 times 5 plus 2 more. So 3 times 5 is 15, 16, 17, and they're all cut up into fifths. So yes, I think that one works as well. This one says 5 times 3, 5 times 3, but subtract 5 times 2/5. So I don't think that this one works because I'm subtracting, not adding. This one says 5 times 12/5. Well, I know that we have 5, 10, 15, 16, 17/5, so the M won't work either. 5 times 2 and 5 times 2/5. I don't see 2/5 in there. Or 2. 3 times 5 and 2/5. Well, I see 3, but I don't see 5 and 2/5. So this won't work either. So we have 4 expressions matching with diagram A. All right, let's move on to diagram B. Diagram B, it's a little hard to see. Let's see if I can get this out here. It's split into 1, 2, 3, 4, 5 pieces again. And this time I have 2 wholes and 3 out of 5. So this is 2 and 3/5. And this is 1, 2, 3, 4, 5 wholes. So that one doesn't seem to match. I see 5 times 2, 5 times 2, but this is 3/5 and this is 2/5. So I don't think that this one matches. Let's look at this one. 5 times 12/5. Well, 1, 2, 3, 4, 5, but this is 10, 11, 12, 13/5. So that one doesn't work. This one says 5, 1, 2, 3, 4, 5 times 3. I don't have, oh, and then it subtracts 5 times 2/5. That might work. So 5 times 3 would be the entire big rectangle. And then I have 5 times 2/5. This is the white part. 2/5 5 times, and I'm subtracting that. So I do think that B and L are the same, so I'll put that one over here. That does work. Now I'm looking at 3 times 5 plus 3 times 2/5. Well, I don't have a 3, do I? I have a 5, but I don't have a 3, so I do not think that J matches. Okay, moving on. 5, 1, 2, 3, 4, 5 times 2 plus 2/5. Again, that's not 2/5, is it? It's 3. 1, 2, 3. 3/5. So that one does not match. Again, that's not 2/5, that's 3/5, so this one doesn't match either. So B only matches with L. All right, let's move on to C. In C, I can see 1, 2, 3 wholes times 1, 2, 3, 4, 5, and 1, 2/5. So this is 3 times 5 and 2/5. Well, look at there. The first equation that I pull up, or expression I pull up, is a match. 5 times 5. Nope, that doesn't match, does it? Nope. 1, 2, 3, 4, 5, and 2/5. This is not 2 and 2/5, it's 3. So nope, that doesn't match. Sorry about that. Again, nope, does not match. All right, let's look at this one carefully. This one says 3 times 5, so I have 3 times 5, and then 3 times 2/5. 1, 2/5, 2/5, 2/5. I think that this one does work, right? This is like distributing that 3. So I think this one works. Let's match that one. 5, 1, 2, 3, 4, 5 times 12/5. I don't see that because if these are all split into fifths, this would be 5, 10, 15, 20, 25, 26, 27 fifths. So I don't think that would work. And then plus this should be 5 if this is a 5. So that doesn't work at all. Okay, I have 5 times 2 plus 5 times 2/5. So 5 times 2, I don't see a 2 here, I see 3's, so that doesn't work. And here we have a 3 times 5 and 2/5. That one works perfectly. So these two equations, or expressions, these two expressions are exactly the same, right? We've distributed the 3 to the 5, 3 to the 5, plus 3 to the 2/5, 3 to the 2/5. So these two are exactly the same, and they match with C. All right, here we go. We have 1, 2, 3, 4, 5 across, 1, 2, and 2/5. So 5 and 2 and 2/5. So here we go. 5 times 2, 5 times 2, plus 5 times 2/5. 2/5, 5 times. That matches perfectly. Here we have a 5 times 12/5. Well, I have 10 here, right? Plus 2 is 12, and they are all into fifths. So yeah, I could think of this as not 2 and 2/5, but 2 and 12/5. 12/5. Okay? 5 times 2 plus 2/5. So that works, right? Because the whole number just has a plus in front, or the addition sign in between them. So that is also the same as this, yeah? Those two are the same. The only difference is I have a plus sign here. So I have 1, 2, 3, 4, 5 times 1, 2, and 2/5. So this one is matching 4 as well. All right, I think we went through every single one of those. Now what we have to do is go through each one again. See, we'll put C here and D here, and we have to find how much is the area that's shaded. How much is the area that's shaded? So we could do this in a couple of ways. For A, I'll put that here. For A, I could count the number of whole squares. That's 3 times 5, that's 15, plus 5 times 2/5. We could do it that way, right? We could take one of the equations that we have in our list here, and solve that. So you get to decide, how do you want to solve it? Do you want to just count? Do you want to move pieces so that it makes holes? You can do it in a number of ways. I think I'm going to solve it this way. So 5 times 3, which we just about did, and 5 times 2 fifths. So this would be 15 plus 10 over 5. And I remember from a previous lesson, let me move this out of the way. I remember from a previous lesson that this fraction sign is the same as a division symbol. So this would be 15 plus 10 divided by 5. And I know that 10 divided by 5 is 2. So 15 plus 2 is 17 square units. All right. So that is the area for A. Let's move on to B. B only has one equation to use, or one expression, I should say, to use. 5 times 3 minus 5 times 2 fifths. And I already know from the work I did up here that 5 times 2 fifths is going to be 10 over 5, which is going to equal 2. So I can go ahead and say that this is 15 minus 2. So this one I think would be 13 square units. And I love that I could use the work that I've already done, these are all equal, right, to be able to solve this problem. All right. Again, I could have just counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 wholes and 5 of the 3 fifths and added all that together, but it made more sense to do it with the expression they gave me. All right, here we go back to C. C looks like this. And we have two equations or expressions to be able to solve this one. Again, I'm going to try this expression. It's the exact same thing. We've distributed the 3 to the 5, and we're going to add that to the distribution of the 3 to the 2 fifths. Okay, so here's C. I'll put C over here. C was 3 times 5 plus 3 times 2 over 5. So this is going to be 15 plus 3 over 1, so that's going to be 6 over 5. Now I know that there's a hole in here. There's a 5 over 5 in there, right? So I can add that 5 over 5 is a 1, and there'll be 1/5 left over, right? So I can subtract out that 5 over 5, which is my 1, and it's going to leave me with a 1/5. So I think the answer to C is going to be 16 and 1/5 square units. All right, last problem to solve today, D. So which expression would I like to use to solve D? I'm going to stick with the distributive property one, right? So D, 5 times 2 plus 5 times 2 over 5. And we've already done that work over here. I know that 5 times 2 over 5 is going to give me a 2. So I can already say that this is going to be 10 plus 2 will give me 12 square units. All right. If you did this in your class with your friends, you'll be able to compare all of the answers that you get with them, see if you get the same answer, and if you don't, ask yourselves, what did you do differently? What did you do the same? And compare your notes. All right, let's go back to our slideshow and do the wrap up. All right, so we did all this. We worked with our partner to show our reasoning. Okay, let's look at C, J, and O. C, J, and O. How does each expression represent the area of the shaded region? Well, there are 3 rows. 3 rows. Let me get a pen here. Thank you. 3 rows, 2, 3. And each row has an area of 5 and 2/5. 5, 5 and 2/5. You write that correctly. So here's my row. That row has an area of 5 and 2/5, right? 1, 2, 3, 4, 5 and 2/5. And I have that 3 times. So I can represent that here. I can represent it saying 3 times 5. There's my 3 5s. And 3 times 2/5. There's my 3 2/5. Or I can just say 3 times 5 and 2/5. So that represents it the entire way, the exact way. All right, now let's look at B and L. For this one, we had to do some subtraction, right? How does the expression represent the area of the shaded region? Well, again, I found the area of the entire rectangle, didn't I? The entire rectangle. And then that was 15. So there were 3 up here and 5 over here. So that's the entire rectangle. This is the entire rectangle. All right. Then I have to be able to see what the shaded region is. I have to subtract out this white part. So that is 2/5. How many times? 5 times. So let's get rid of some of these things in here. There we go. So this is 2/5. This is 2/5. And so on and so forth. So I found the area of the entire region, and then I subtracted out the white part, the 5 2/5. So that's how that expression shows that diagram. Okay, write as many expressions as you can to match the area of the shaded region. As many expressions as you can. So let's look at that. Well, I see a 4 over here. Okay, a 4 over here, and I see 1, 2, 3, 4, 5 whole ones, and then I see a 1/3. So I could write 4 times 5 and 1/3. I could write 4 times 5 plus 4 times 1/3, right? I could say 4 times 6, 1, 2, 3, 4, 5, 6, minus 4 times, what is that? 2/3, right? 2/3. So finding the whole rectangle and then subtracting out the white part. Let's see, are there any other expressions that we could use? Those are a lot. We could say 4 times, and then how much is this? 3, 3, 3, 3, 3. That's 15, 16/3. So we could say it that way as well, couldn't we? So I have 1, 2, 3, 4 ways that I could have written that. Maybe you found even more than that. All right, let's look at number 2. 1, 2, 3, 4, 5, 6, 7 across the top. 1, 2, 3 holes, and I got 3/4 of the last one. So again, I can say 7 times 3 and 3/4. I could say 7 times 3 plus 7 times 3/4, right? 7 times 3, 7 times 3/4. I could say, let's see, that would be, if these were all split into fourths, this would be 4, 8, 12, 13, 14, 15/4. So I could say 7 times 15/4. Or I could say, what's the area of the whole rectangle? So it'd be 7 times 1, 2, 3, 4. 7 times 4 minus what's left? 7 times 1/4. All right, good work. We got 4 equations for each one of those diagrams. I keep saying equations. Those are expressions, aren't they? Expressions. There we go. An equation has an answer. An expression does not. All right, write expressions. How does each expression represent the first problem? Did your approach change when writing expressions for the last diagram? All right, so how does each expression represent the first problem? Well, I see 1, 2, oops, doing it again, Miss Lemoyne. Get your pen. There we go. I see 4 on this side, 1, 2, 3, 4. I see 1, 2, 3, 4, 5 across, and then I see a 1/3 here. So that definitely represents this one. To say 16/3, I count each individual one, right? So my 4 stays the same because these are 4 holes. And then I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And they're all split into thirds. Nice job. All right. So you might want to discuss this with yourself or your friends or make some notes in your book. What was your favorite way to find an area of a shaded region? What is a new way that you're excited to try or learn more about? All right, now we have our cool down. Select all the expressions that represent the area of the shaded region. Well, before I even look at those expressions, I'm going to go ahead and mark my diagram so I know what I'm talking about. So over here we have a 2, 1, 2 holes. Over here we have 1, 2, 3 holes, and then I have 2 out of 5, right? 2/5. So I notice that this one works because I have 2 times 3 and 2 times 2/5. So I'm going to mark A. This says 6 and 2/5. 6 and 2/5. Well, I don't think that that works because I can see where they got that though. 2 times 3 is 6, but then they just copied the 2/5. They didn't do 2 times 2/5. And there are 2 of them there, right? There are 2 of them. So I don't think that would be correct. This one says 2 times 3 plus 2/5. I agree with that. So this is my 2, and this is my 3 plus 2/5. So I'm going to circle C. All right, this one says 2 times 4, 1, 2, 3, 4. So that's the entire diagram. And they're subtracting out 2 times 3/5. Is that 3/5? Yes. So I think D is correct. E. E is the same thing as B, isn't it? It's 2 times 3 and then adding 2/5, but that doesn't work. We have to do 2 times 3 and 2 times 2/5 and add those. So I don't think E works. 17/5. So that means I'm going to have to count how many fifths would be all right here. Well, this would be 5, 10, 15, 16, 17. And yes, I think 2 times 17/5 would work. So, wow, a lot of answers this time. A, C, D, and F. All right. I hope that made things clear. I'll see you next time. Please remember to like and subscribe so I can continue making these videos for you guys.